Hello everybody. From now on, as you can imagine, we are gonna continue our lessons through YouTube. I'm gonna upload one lesson every day, every week on YouTube, and you're gonna follow it from there. I will share the link on the Google Classroom. Every week there will be one lesson, so there will be one video around 30 minutes, 40 minutes. And there will be related questions on Google Classroom, so please follow up everything in the Google Classroom carefully. So basically what we are doing in class, in school, we are just doing similar way, one lesson every week. So this week's lesson is going to be a little bit more what we were learning before the break, spring break. It was 7-4, it was half angle identities, it was double angle identities and sum and difference formulas. So we'll discuss them, we'll work on them again, and we are gonna look at the questions that I assigned for AMI days for the last week. So by the way, I am extending the time for the homework that I assigned to you. Looks like there are a lot of questions coming about actually the half angle formulas. We'll talk about them. So I will solve some of those questions. So I will ask you to solve the rest and upload it on the Google Classroom. Plus there will be another assignment for this week, so I want you to follow this video, take notes, and do the rest of the questions on the last week's assignment, the AMI days. It's like last week's assignment, and do the assignments for this week. So that's what expected from you for this week for the Algebra 3 lesson. So before we start, remember we were discussing about the double angle formulas, and 1 week before that, that was the sum and difference formulas we were working on. So we will look at them again, as I said. So looks like when I assign you the questions, there were questions saying something about that half angle formulas here, right here. So what are they? It's just like double angle, but it's half, as you can see. If you know what's the full angle that's given to you, if you are looking for what's the trigonometric ratio of the half of it, like a over 2, here sine a over 2, cosine a over 2, whatever, we are calling them half angle formulas. These are not a new type formula. It's just like coming from the double angle formulas. We just adjusted them and create a new formula set to you, those three ones again. But I prefer to use double angle formulas most of the time. Here we can also use the half angles, which is not that much essential, but since some of the questions specifically tells you to use the half angle formulas, so it's good to talk about them a little bit. Alright, so it looks like sine, cosine, and tangent, as I say all the time, these are the three most important ones. If you know these three, the others are fine. The cosecant, secant, and the cotangent, which are the reciprocal of these three trigonometric ratios. So basically sine a over 2, if you have it, if you are looking for the half of that given angle, it is plus minus square root of 1 minus cosine a over 2. Cosine a over 2 is the similar, again plus and minus. As you can see, all of them have the plus and minus all the time, but this time we have a plus sign here. And tangent has the minus and plus. It looks like it's like a ratio of cosine, 1 minus cosine and 1 plus cosine. So these are the three ones that we may need to use for some questions. So let's start with the very first one. So the first question is saying that sine 1 over 5. What is the sine 1 over 5? Use the half angle identities, the one that is the one that we can use here to calculate sine 1 over 5. So that's always that we have three formulas here. Looks like we are going to use this one because we are looking for sine something, so it's definitely this formula. So if you put the formula down here again, sine a over 2 is just equal to plus and minus 1. If you wonder why we have plus and minus, it's because you square root it. If you square root things, there will be plus and minus in the front all the time. That's the reason why. So it looks like this is the formula we are using. Right? So I can tell a over 2 here is 105, right? A over 2 represented by 105 here. So I need to know what's the angle A. If A over 2 is 105, that's so easy to find what's A. You just multiply both sides by 2 That's a 210. If you multiply 105 by 2, that's 210. So it looks like the angle A actually that we need to plug in the formula here, the right hand side, is at 210. So what I'm gonna do is that if I'm looking for sine 105, I will just do 1 minus cosine 210 over 2 and the square root and plus and minus. Looks like we may have two answers here. If you check the chart, remember this chart that we need to know what's cosine 210, also attached to Google Classroom, and it's also here, right over here. I will just keep this one here all the time so that we can use it like this. We want to know what's cosine 210, right? 210 is here, and if you look at the cosine right over here, we have negative root 3 over 2 for the cosine 210. Alright, so cosine 210 is equal to negative root 3 over 2. So the answer so far we should have is this: 1 minus negative root 3 over 2 over 2. The negative root 3 over 2 is for the cosine 210, and the negative sign is here, as you can see. So it will be just, if you fix it, it's gonna be 1 plus root 3 over 2 over 2, the common ratio. So the answer will be this, plus and minus. Alright, we can continue and fix this more and see what is that equal to in the simplified form, but it's not our job right now. It's more radicals. We are working on trigonometry here, but I can tell trigonometry is so related to radicals, so we can leave it at this point. But if you want to see what is the decimal answer, use a calculator. Make sure you type this in correctly as it is, as you see here, and see what's the answer. But this is fine, this is acceptable. Alright, so the first answer is plus minus square root of 1 plus root 3 over 2 over 2. I know the answer is not something very cool like a whole number, but that's okay. We are working on trigonometry. It's obvious that we may have this kind of answers. Okay, so make sure you guys are writing this down. Okay, take notes, because that's how math works. Okay, so let's clear this one, and let's look at the question 3 here, and let's see what we can do for this one. I'll just put this up here so that I can use enough space. Sine 345, right? So it looks like we are still looking for on sine, right? Sine is here. I can tell, if you remember the formula again, the a over 2 will be 345. So let's write that. Hold on. Let's choose the different color. Got something wrong with this. Looks like the pen is not working. Let me fix this, and we will continue. Alright, so sorry, there was a technical problem. Looks like it's gone. Alright, so the question 3 is about sine 345 is what, right? So to find this one, we need to know that sine a over 2 is again the formula that we are using. So looks like a over 2 here is at 345. That makes a is, if you multiply both sides by 2, you get a 690. It's a very big angle, I know, but we will use the sine 690 here to find the sine 345. So sine 345, basically if you use the formula, that will be plus and minus 1 minus cosine 690 over 2. This is going to be our answer. If you check what is cosine 690, that's obviously this angle is more than 360. So we need to normalize this angle. Remember, if an angle is more than 360, you can just subtract a 360 or 360s as much as you want to make it normal. So basically, to find what's that 690 equal to, we will just subtract a 360 from this angle. If you do the math, you will see it's actually 330. So the coterminant angle of the 690 is 330. So the question will turn into this: plus minus 1 minus cosine 330 over a 2. This is gonna be our answer. Alright, so to find that again, cosine 330 is what we need to know. Now it's time to check the chart. If you go back to chart, we will see it over here. The value of that cosine 330 is actually a positive square root of 3 over 2. Cosine 330 is equal to positive square root of 3 over 2. So we will use this one. Alright. So 1 minus, I'm putting the questions here now, 1 minus cosine 330 is equal to square root of 3 over 2. So 1 minus square root of 3 over 2 over 2 is what we can have an answer. Yeah. So the answer will be this. Of course, plus and minus will be right over here. 1 minus square root of 3 over 2 over 2 under the common square root will be the answer. You can leave the answer this way, or if you want to, you can just convert this one to a decimal. Both ways is fine. So basically question 3, 4 are this way also. You will use the correct formula type and plug it in there and simplify as much as possible and get the answer. So question 8 is more. Now we will use the double angle formulas. It didn't specify that use the half angle, so I prefer the double angle here. This is more than what you will see. You are looking for sine 2 theta. Remember the formulas. Cosine 2 theta has 3 options. Cosine squared a minus sine squared a. Cosine 2a is equal to 1 minus 2 sine squared a. And cosine 2a is also 2 cosine squared a minus 1. But for sine 2a, we have only one option. That's 2 sine a and cosine a. And tangent 2a is just 2 tangent a over 1 minus tangent squared a. So we have 3 options for cosine. 1 only for sine, 1 only for tangent. Since the question is asking sine 2 theta, we can tell this is 2 sine theta cosine theta here like this, right? So it looks like to find this, we need to know what sine theta and cosine theta. Luckily, we are given cosine theta, but we need to know sine theta. First, we have to see where this angle belongs to. Looks like this is more than 90, less than 180. That's basically the second quadrant. So remember, we are going to use this one to define what's the sine of the sine theta. So to find this one, let's just start over. 2 times sine theta. Since we don't know that, I will skip it and I will just write what's cosine theta given to us. That's a negative 8 over 17 here. Negative 8 over 17 times something. We will find this out. How? By making our triangle like this one, a triangle. Let's assign the theta here. Since cosine theta is negative 8 over 17, cosine was the adjacent over the hypotenuse. There you go. And you need to find the missing side. If you do the math, the Pythagorean theorem that I'm leaving to you, you will find this out. That's a 15. So this is actually 8, 15, 17 special triangle. So if you are looking for cosine, sine theta will be actually opposite over hypotenuse. That's a 15 over 17. Positive or negative? Since second quadrant, sign is positive, so the answer will be positive 15 over 17. So just copy the 15 over 17 here. That's gonna be our final answer. 2 times 15 over 17 times negative 8 over 17. If you multiply and do the math, you will see it's a negative 240, I guess. 2 times 15 is 30, times 8 is 240, and minus here in the front, over 17 times 17, that's a 289. So the answer for sine 2 theta will be a negative 240 over 289. That was question 8 on the first exercises set. Let's do another one on the exercise set 10, and let's see what we can do. Look at the previous question, and this one, it was asking you to find what sine 2 theta. It was asking the double angle, but it looks like we are given the theta here, but we are looking for the half of it. Yes, we can use the half angle formula here for that. That's definitely fine. Or just apply the double angle formula to find it. Both ways okay. Okay. So for example, let's make our job easier and let's go back to the very beginning and look at what's tangent a over 2 equal to. That was a plus minus 1 minus cosine theta over 1 plus cosine theta. We can even use this one to find the answer. 1 minus cosine theta over 1 plus cosine theta. Alright. So if I'm looking for this, basically it will look like that. 1 minus cosine theta, 1 plus cosine theta. So 1 minus cosine theta, so cosine A here, over 1 plus cosine A. So since it's theta, I think I should change it to a theta. That will be better. This is a theta. This is also a theta. 1 minus cosine theta over 1 plus cosine theta. This is better to say. Okay. Alright, so looks like we are given tangent, and looks like this tangent, the theta, angle theta, belongs to the third quadrant, because between 180 and 270 makes it the third quadrant. Looks like, again, we need to make a triangle to find out the sine and cosine. Looks like we just need cosine here. That's better. So theta, remember tangent theta was opposite over adjacent. That's a 4 over 3. If you find the missing side, that's definitely 5. So the hypotenuse will be 5. We are looking for cosine theta for the formula that we will use here. So cosine theta will be definitely 3 over 5, because adjacent over hypotenuse, 3 over 5. And since third quadrant, cosine is negative, so negative 3 over 5. So now go back to question. Tangent theta over 2 is what we were looking for, and the formula plus and minus says we should have 1 minus cosine theta. So 1 minus negative 3 over 5 over 1 plus negative 3 over 5. 1 plus negative 3 over 5. These all are under the same square root. Okay, so that's the answer. So we'll just fix it, and that will be our answer. Remember, we prefer to use the half angle formula here to find the answer. Maybe that was a shortcut, but definitely we could get the same answer by using the double angle formulas. So plus and minus, I will just do faster here to simplify what's given. If you do the math here on top, that's actually 8 over 5 over the bottom will be just a 2 over 5. So this is an 8 over 5 or 2 over 5. Sorry for my handwriting, it's a little hard to use this mimeopad. I will do my best. So do the math inside the square root, you will just get a 4. That's a 4 square root of 4 plus and minus. So we will have plus minus 2 as the answer for tangent theta over 2. But which one we will use? Is it 2 or negative 2 is the one that we are looking for? both are correct answers, but since we are looking for the answer in the third quadrant, and we know that tangent is positive in the third quadrant, we will say tangent theta over 2 is gonna be a 2 here, the answer. That's the answer for question 10 on assignment 1. Alright, so let's do one last. I think this is the one last. Oh, actually we have two. So let's see one last question. That's on assignment 1, question 12, and see how we can solve this question. Cosine theta is given. We are looking for sine 2 theta in this question. It's in the first quadrant, as you can see. Pretty naive question. We can handle that. If you follow the formula for sine 2 theta, if you are going to expand it, this is where we will use it. The 2 sine theta, cosine theta is what we have, right? So 2 sine theta times cosine theta. So basically, we know what is cosine theta, but again, we don't know what's sine. So the triangle is what we will do again. Here, at theta right here, that's cosine. It's adjacent or hypotenuse, so that makes it a root 255 over 16. 16 is going to be the hypotenuse right here. If you do the math here, the Pythagorean theorem, what will be the missing side? Interestingly, if you square the 16, that's a 256. This is 255. It's just one more. That's going to be the opposite side. Opposite side will be 1. Pythagorean theorem again will get you what is the missing side. That's 1 over here. So, since we are looking for sine theta, that's gonna be just opposite over hypotenuse, 1 over 16. Since first quadrant, that's positive. Alright, so let's finish the question. 2 times 1 over 16 times root 255. Root 255 over 16. Let me write this again. It's hard to read. Oops. Times root 255 over 16. Simplify. 2 times 1 times root 255 is just 2 square root of 255. 16 times 16 is just 256. Maybe the 2 and the 256 can simplify. We can have a root square root of 255 over 128 as the simplest answer for sine 2 theta. Okay, so we have one job again. Look at the question, what you are looking for, and look at the formula that is the appropriate formula that you will use. After expanding the formula, see what you need to use. In this question, we were given cosine, we were good with that, but sine we don't know. That's why we made the triangle to find out the sine value of the theta and put them all together in the formula and do the basic math and get the answer. That's how we are gonna do if we are using double angle formulas. One last question. Let's also do this one because this is a tangent. We never did a tangent question of these double angles. So you can tell that, right? We are given tangent. We are looking for cosine 2 theta. Look at cosine 2 theta. We have 1, 2, 3 options for that. Right? Doesn't matter which one we will use. Let's pick this one. I'm gonna use this. I will say cosine 2 theta is actually equal to 2 cosine squared theta minus 1. That is the formula again. Since I need to know what's cosine, right? But I'm given tangent. So guess what? Again, the triangle. We'll make the triangle here. Theta is somewhere here. By the way, remember where does this belong to? That's the first quadrant, right? So tangent is opposite over adjacent. So opposite of the angle theta is a 6 root 2 and the adjacent is 17. If you do the Pythagorean theorem, you will definitely see that is the square of 17 is a 289 and the square of 6 root 2 is 72. 72 plus 255. I'm just adding the squares of them. Do the Pythagorean theorem, guys. I'm leaving this to you. You are gonna get a 361. That's definitely the square of 19. So you will see this triangle is a 17, 6 root 2 and 19 triangle. Okay? You will always get the missing side by applying the Pythagorean theorem. Alright, so that's what we have. So since I need the cosine theta, that's adjacent over the hypotenuse, 17 over 19. Since this is first quadrant, in first quadrant all the ratios are positive, so this is also positive. So let's go back to the question. Cosine 2 theta, 2 times cosine squared theta. Cosine theta is 17 over 19. Then I'm gonna square this one and subtract a 1 from that. That is a 289. If you square the 17 over 19, that's a 361 down here, and minus 1, right? So this is what we will have. If you do the math, I'm gonna leave this to you. Just do the math, multiply the 289 by 2 and subtract about 1 from that fraction. This will be the answer. Okay, I'm leaving the answer to you. Multiply the 289 by 2 over 361 minus 1 will be our final answer for the cosine 2 theta. Let's go to the second part. This is now on the assignment 2 that you will see the sum and difference formulas. That's actually before the double angle formulas, but somehow I assigned it as assignment 2. So we are doing it the second place. Remember what are they? Cosine A plus B, cosine A minus B again, sine A plus B, sine A minus B, tangent A plus B, and tangent A minus B. Remember, cosine was the selfish one. It is always with cosine, and sine comes later. Sine always goes with together, sine cosine way. And tangent just needs tangent by itself, like tangent A plus tangent B over 1 minus tangent A times tangent B. So remember these formulas again. If you want to go back to this, just pause it and see what are the formulas again, but I will have them all in the upcoming slides. Alright, so first question. This is assignment 2 again, remember, assignment 2. Question 6. I prefer to start from 6. We have tangent negative 5u minus tangent negative 4u over 1 plus tangent negative 5u times tangent negative 4u. By the way, before we start, they should have put parentheses like that. So whenever you see a negative angle like tangent negative 5u, it doesn't mean that you're subtracting 5u from tangent. It's just actually the tangent negative 5u, like the angle is negative. Okay, so same thing here, but I'm not gonna write them on the bottom, not to make it like hard to see, but just know the fact that when they say tangent negative 5u, they meant the tangent negative 5u. It's not minus 5u. Okay, so now look at the formula. Which one do you think we will use here? We have a plus here, but in the formula we have plus. When we have minus here on the it's like tangent. Oops. When it is looks like it's acting out again. Wait a second. Alright. So here, so if we look at again, we are going to use the negative version of the formula because we have negative tangent A minus B, tangent B. So this will turn into that. Okay. Tangent negative 5u minus negative 4u, because it is tangent A minus B, like this one. tangent negative 5u minus negative 4u. A is negative 5u, B is negative 4u. So basically it's going to turn into tangent negative u only as the answer for 6, and that's it. Same thing for question 8. You see we have positive numbers here, that's cool, but we have the negative sign here, right here, between tangent 2u and tangent 6u. Looks like again the same formula, so it will be just tangent 2u minus 6u, which is gonna come up with again a tangent negative 4u. That's the answer. Alright, so let's look at the last two questions, 11 and 13. That's again on the assignment 2. Look at this, sine 58 times cosine 13 minus cosine 58 times sine 13. And look at the second formula here. We have sine A times cosine B minus cosine A times sine B. So looks like A is 58, B is at 13. Again, A is at 58, B is at 13. So as we say, this is the second formula because of the negative sign in the middle. So that looks like a sine A minus B. That's at 58 minus 13. So sine 45. We know what's sine 45. You can just finish here or just say what's sine 45. If you check the chart, you will definitely see it's the square root of 2 over 2. Similar stuff. A, B, A again, B. And it's like sine A times cosine B minus cosine A times sine B, which is definitely again the second formula because of the negative sign in the middle, subtraction sign. So this is going to come up with a 394 minus a 169. If you subtract 394, if you subtract 169 from 394, that's definitely sine 225. And we also know this one from the chart. The 225 for the sine is negative root 2 over 2. So it looks like that will be our answer. Negative square root of 2 over 2 will be the answer. Alright, so these are the questions. Again, we solved almost half of them. So I'm extending the due date for this assignment, these two assignments. I will extend it again. I will also upload another homework on sum and different formulas, double angle formulas and half angle formulas. Please work on them. Submit your answers, worksheet, not just the answers. Show your work like as I show here, and upload it. If you will have any question, just like I mentioned last week, write the assignment number and the question number on the private message on the Google Classroom and share with me. I will help you as much as I can do. So this was the first lesson. Probably next time it's going to be much better. Once we get used, it will be better. Let me know if you will have any question. I will be waiting for it. Alright, take care everybody.